Well, my life is still a chaos of unpacking U-Haul boxes back there. My old house still isn't empty. The tech news must go on, so let's roll with it. Why is the tech news so chaotic? Well, one thing is AMD recently delayed their 9000 series processor launch. But why though? AMD was hesitant to give an exact reason, talking about not qualifying or not passing all of their testing or quality assurance. Well, the point is that they didn't quite give an actual explicit reason. Could it be as simple as a typo on the CPU themselves? So that is what appears to be emerging as the leading candidate, because look at this photo. We have an AMD Ryzen 9 9700X. And at first you might just skim past that and be like, what's the issue? The issue is that the 9700X is not a Ryzen 9, it's a Ryzen 7. There's also reports that the Ryzen 5 9600X CPUs could also be labeled as Ryzen 9. So it's possible that this is the issue that triggered this whole, delaying of the launch and pulling product out of the, out of production and not production, but out of channels, retail channels, all of that. Anyway, we'll have to see if that ever gets confirmed as the real reason why this all happened, or perhaps it is one issue and maybe there were other issues as well. And this could maybe have been only one of the things that wasn't caught by quality assurance and testing, but that would certainly be interesting. Now, we got a whole bunch of other stories to talk about, but since we're on the AMD side of things, how about we just continue with that? So we're also seeing, again, that since these CPUs were already out there, there are definitely results being published for performance numbers, including Cinebench numbers, where we are seeing 10 or 11% performance bumps compared to the previous generation. Now, that's not massive, but it's also unclear exactly what, performance numbers we're using. It was PBO enabled, so with PBO enabled, AMD was claiming that we should see some pretty big jumps, at least on certain CPUs, if you use PBO. So again, we really kind of need those full reviews, and it's not going to be too much longer now before we get them. So let's go ahead and move on to this AMD news, switching over more to the GPU side of things, although also NPU side of things, depending on which product you're looking at. AMD is introducing Amuse 2.0 beta with AMD XDNA Super Resolution, a fully local AI experience. Now, when I first saw the headline AMD XDNA Super Resolution, I was like, oh, is FSR finally getting an AI accelerated version? Please tell me yes. The answer is no, at least that's not what this is. Could there eventually be some version of that applied to games? Sure. But what this is actually talking about, so the Muse 2.0 beta here actually looks similar to what I reported on my last news video regarding Intel releasing some software for their Arc GPUs to make it simple and easy to for users with maybe not a lot of technical experience with the AI stuff to just get some AI stuff up and running on their hardware in a format that's already set up well for it. That seems to be what we're seeing here. So AMD is introducing Amuse 2.0 beta. And the goal here, if you take a look at it, is to make it an easy-to-install program that has no dependencies, a simplified user interface called Easy Mode, and will quickly take care of all the configuration required to jumpstart your AI image generation journey. Now, that's the key here, is this appears to me to be just AI image generation, whereas Intel's versions seem to also support like large language models. I can't speak. Anyway, but again, this does also feature AMD XDNA Super Resolution to speed up and increase output size by 2x at the end of the image generation stage. So for example, you could do an image at 512 by 512, and then it could upscale using XDNA Super Resolution to produce a 1024 by 1024 image. That's kind of what they're talking about here. The highlights are no command line needed, simple and easy to use, AMD XDNA Super Resolution, single executable, no dependencies, auto configuration and model selection, paint to image, drawing to image, create your own AI filters, multi-stage ONNX based pipeline, stable diffusion, control nets, feature extractors. So if you're interested in AI image generation on AMD hardware, but you didn't, maybe know really where to get started with all of that, perhaps this would give you a simple way to get into it. But as far as support goes, right now it looks like this is supporting, at least official recommended system specs. So I haven't tried running it on things outside of that yet, but they're saying recommended system specs are AMD Ryzen AI 300 series processors, which we're getting reviews of today, more on that later in the video, with 24 gigabytes of RAM or higher. AMD Ryzen 8040 series processors, which have AMD XDNA Super Resolution support because they have the NPU, but you would need the latest OEM MCDM and NPU driver update. And these would suggest 32 gigabytes of RAM and Radeon RX 7000 series graphics cards. Notice that AMD 6000 series is not currently listed here. It's unclear why exactly or when or if that will be expanded. Want some shots of what this tool actually looks like. There you go. So again, you could write something here and then get it generated like this if you do it as cinematic bread. So giving some idea of what this tool is capable of if you want a robot squirrel with red eyes with an artistic blend. Cool, there you have it. Again, to support the XDNA Super Resolution feature, though, I think you do need the XDNA NPU feature, so your hardware does need to, you do need to have the correct hardware for that. Now, in a bit less easy to use and understand, but I think extremely interesting side of things, I've been reading through some AMD published papers about their research into some graphics technologies that I think could be used to greatly improve ray tracing performance in general, but also in really specific situations and possibly also take advantage of AMD-specific hardware on upcoming graphics card launches. So one thing that they're talking about here is DGF. Now, all of my sources will be linked in the video description. So honestly, this is a bit technical, and parts of it I can understand and parts of it go a bit over my head. So anyway, just warning you, you will, if you read into this, see things like this. But if you want to play around with this, or at least read the more easy to understand, introduction paragraphs and whatnot, this seems pretty interesting. So with the introduction of Unreal Engine 5 and one of its absolute key features being nanite, it poses a significant problem for ray tracing. Because, again, if we kind of quote this here a bit, the major graphics APIs now offer standardized support for accelerated ray tracing, but in the same time frame, rasterization-based systems such as nanite, again, one of the key Unreal Engine 5 features, have significantly raised geometric complexity in games. So the idea is that nanite allows extremely high geometric detail, but then it's constantly changing on the fly from frame to frame to only show you the parts that are actually needed. The problem is that this trend conflicts with current ray tracing interfaces, which require opaque acceleration structures to be built from uncompressed input data. So the idea is that the way you would currently be tracing against things conflicts with the constantly changing geometry that's being used in nanite. And so the idea here with DGF, a dense hardware-friendly geometry format for lossily compressing meshlets with arbitrary topologies, is that it would be more compatible with systems like nanite, which is extremely interesting. One of the problems suggested in the paper, though, is that the decompression part of this would currently be too expensive. But what if you had a future fixed function hardware for that decompression? In other words, if in a future AMD graphics processor had a fixed function hardware piece designed to do that decompression, it could actually vastly accelerate or become more at least compatible with systems like nanite to ray trace against, which is really interesting. And for them to be publishing this it tells me that perhaps they've already designed that fixed function hardware and have it coming up. Are we going to see this in the PS5 Pro? Are we going to see this in, the RDNA 4 architecture, something like that? But anyway, no guarantees on what's coming, but that is very interesting. And again, you can read more of this paper as linked in my video description if you're so inclined. Another paper that looked really interesting to me was, would you pronounce this H-PLOC? So what is that? Hierarchical parallel locally ordered clustering for bounding volume hierarchy construction. So let's read the introduction here a little bit. Again, I think this one's a little harder for me to summarize exactly why it's cool, but they propose a novel GPU-oriented approach for constructing binary bounding volume hierarchies. You may have heard of BVHs if you've looked into ray tracing a bit. It's a huge part of ray tracing. Based on the parallel locally ordered clustering algorithm, compared to competing high-performance GPU BVH build algorithms, our method provides similar BVH quality in just a single kernel launch, while achieving 1.1 to a 3.6 times lower construction times for the entire BVH build and 1.6 to 13 times lower for just the binary BVH construction phase. Additionally, we propose an efficient algorithm to convert a binary BVH to an n-wide BVH with just a single kernel launch. Besides being extremely efficient, our proposed algorithms are simple to implement, allowing easy to integrate into existing frameworks. And it gets more complicated from there. However, if all of that went over your head and some of it goes over my head, my general idea of what they're saying here as I read through this is this could propose a good balance, I think, between... So you can, I think there's time spent constructing the BVH and then time spent ray tracing against the BVH. And there can be a balance there between if you maybe you spend longer constructing the BVH, it might be harder to, easier to ray trace against. But if you don't spend as much time on the construction of the BVH, it might be longer to ray trace against, and the idea here seems to be finding a good balance with that. So that's my interpretation of it. Again, best as I can do it. A lot of this is a bit above my head, but what I'm generally getting out of both of these papers and some other things we've seen from AMD recently is they're putting a lot of effort into researching ray tracing, and there's just a lot of evidence that could be getting better in future AMD hardware and software, which is pretty interesting to me. This looks to be trying to strike a good balance between BVH construction time efficiency and ray tracing against it efficiency as I see it. Now, speaking of AMD, they have some new hardware with reviews coming out today. This is their Ryzen AI 9 HX370. We're seeing some laptops getting tested. A lot of them seem to be ZenBooks, like the ZenBook 16. There's also a 13. Now, one thing that seems to be a bit confusing about these is that unlike previous AMD mobile hardware, they were a lot more clear about exactly what wattage it would be running at based on the name of the chip, like HS or HX and things like that. That seems to be less the case here, so you will need to probably research the specific laptop you're getting a bit more carefully to see what power profile it's running in. But a really interesting thing I saw in the computer-based review, I'm having it machine learning translated to English here, is that their performance profiles, based on 33 watt versus 28 watt, for example, in 3D Mark Steel Nomad Lite, notice it's interesting that the 28 watt is coming ahead of the 33 watt profile, which is very interesting. Now, it didn't happen in every test. So in other things like 3D Mark Port Royal, they're seeing the 33 watt ahead of the 28 watt like you would expect. But why would that be happening? Well, it could be due to the GPU and CPU fighting for the wattage and thermals. So perhaps in the higher powered mode here, it could have been seeing the CPU maybe taking too much from the GPU as it went into a higher power state, something like that. I don't know. Interesting Just something to keep your eye out for. But what is also interesting is notice that the 28 watt version is not only beating the 33 watt on the same chip and laptop, but it's beating a 54 watt Ryzen 9 8945HS Razer Blade 14, which is interesting. And also, of course, beating the 42 watt and 37 watt versions of those. So there certainly does seem to be an efficiency increase here with better performance, while also doing it at a lower power profile, although the overall performance jump isn't massive here. Like we can see, comparing the 28 watt to the 37 watt on the Ryzen 9 8945HS Razer Blade 14, we're seeing like a 14% performance increase. But again, it is doing it at a lower power budget, which is interesting. 3D Mark Port Royal showing, a 7% increase here, but again, it is doing it at a lower power target. And if you look at an actual game like Cyberpunk 2077, you can see, again, comparing the 33 watt to the 37 watt previous generation, we're seeing like a 5% higher frame rate, but again, it's doing it at a lower power target. They also show the HX370 laptop down at 17 watts, which is at least interesting to kind of take a look at and see some of that scaling. There's a bunch of other reviews out there. Linus Tech Tips had one of the first ones out that I saw today with AMD through the match but won anyway. Strix Point Ryzen AI 300 review. Here they're seeing good gaming performance in like Shadow of the Tomb Raider. And again, especially good compared to like the Qualcomm chips out there, which don't have the most amazing gaming support. Also seems to be beating the latest Intel mobile chips. We're also seeing Notebook Check with some reviews out there. If you look at their 3D Mark performance rating, for example, you can see that the versions of this with the Ryzen AI 9 HX370, again, are at the top of the pack on their performance ratings, but again, not by a wide margin. So it's looking like the GPU performance and gaming performance on these new chips is better than previous generations, and it's also better than what we're getting from the ARM chips that recently launched, as well as better than what we're seeing from Intel competition in AMD's previous generation, and it's doing it with a lot of power efficiency, but just the overall raw performance gain, at least on the 33 watt laptops that we're getting the reviews off of, don't seem to be just like leagues ahead or anything like that. I also looked at AnandTech. And again, if you want to look at like the CPU, like Cinebench scores and things like that, again, they are coming out on top. And again, doing it at a 28 watt setting here, beating things like the Ryzen 9 7940HS Razer Blade 14 at 35 watts. So, it is certainly interesting that they're able to do that. But again, the overall performance jump isn't just absolutely massive or anything, but the efficiency does look pretty good. At least from what I'm seeing here. Now, one thing when you're looking at comparing these up against, for example, the Qualcomm competition with the ARM chips, one thing I've noticed, and I was reading some headlines about this too, is most of the Qualcomm laptop reviews weren't featuring the top-tier Snapdragon X-Elite processor. And as far as I can tell, it seems to be only one laptop out there with the top-end Snapdragon X-Elite. So I was reading through this article kind of talking about why at Laptop Mag, but a lot of it just appears to be, in the laptop form factor, what you're targeting is the full laptop design and experience, which a lot of times is based on the battery life and efficiency of the system and what's the peak in the, efficiency curve. And perhaps the top end performer for the Snapdragon X-Elite isn't actually what you would maybe want in a laptop, but we'll have to wait and see if maybe we'll just get a later wave of more powerful systems or something like that. But anyway, one of the biggest stories lately in tech news has been the crashing Intel chips. And The Verge has issued a bunch of questions to Intel, and they have received answers, at least for some of their questions. But unfortunately, the answers may not be what you wanted to hear. So let's look at a couple direct quotes from them. I'm going to switch over to some sites that quoted that article, but with a nice darker background to avoid too many flashbangs for you guys. Anyway, so with all of these chips being having these issues, will Intel issue a recall? Short answer, no. Has Intel halted sales and or performed any channel inventory recalls while it validates the update? No. Will Intel extend its warranty on these 13th and 14th gen parts, and for how long? Waiting for Intel to reply to that one, apparently. Given how difficult this issue was for Intel to pin down, what proof will customers need to share to obtain an RMA? How lenient will Intel be? You guys hear the crickets? No. Anyway, so in other words, Intel has been saying a lot about how, reach out to them if you have issues and that kind of thing, but they're awfully quiet on extending warranties, how easy it will be to get an RMA. Now, why would they maybe want to do a recall or maybe should do a recall? Well, this is also from the same series of questions, how many chips does Intel estimate are likely to be irreversibly impacted by these issues? Well, here's the response from Intel. Intel Core 13th and 14th generation desktop processors with 65 watt or higher base power, including K, KF, KS, and 65 watt non-K variants, could be affected by the elevated voltages issues. However, this does not mean that all processors listed are or will be impacted by the elevated voltage issues. Wait a second. So Intel's saying basically every 13th and 14th gen chip, including 65 watts or higher. So we're not just talking the Ryzen 9 chips that seem to be exhibiting the issues now. So basically, almost any desktop chip you might have could be affected by the elevated voltage issues. However, this does not mean that all processors listed are or will be impacted by the elevated voltage issues. So does Intel have no idea, really? I mean, and Intel continues validation to ensure that scenarios of instability reported to Intel regarding its 13th and 14th gen desktop processors are addressed. Addressed how exactly? Anyway, for customers who are or have been experiencing instability symptoms on their 13th and or 14th gen desktop processors, Intel continues advising them to reach out to Intel customer support for further assistance. Notice they're not saying they're just guaranteed to replace it for you. Notice that. They're saying to reach out. They're not saying what they'll do once you reach out. I'm just making sure we're all reading that clearly, okay? Additionally, if customers have experienced these instability symptoms on their 13th and or 14th gen desktop processors, but had RMA, return merchandise authorization requests, rejected, we ask that they reach out to Intel customer support for further assistance and remediation. So it's saying if you were denied before by us, reach out again. Notice they're not guaranteeing at any point that they'll actually, give you the RMA this time for sure. Maybe they will. But are they going to pause selling these chips while they're known to be defective? Nope. Are they going to recall any of the chips that are known to be defective? Nope. Will they extend their warranties? Crickets, right? Anyway, how lenient will they be on getting that RMA? Crickets. I'm just saying, I think Intel could be handling this situation in a bit more clearly consumer-friendly way. That's what I'm saying here. There's a bunch of other interesting questions here, will Intel proactively warn buyers of these chips about the warning signs or that this update is required? And if so, how will it warn them? Reply from Intel. Intel targets to release a production microcode update to OEM ODM customers by mid-August or sooner, and will share additional details on the microcode patch at that time. Intel is investigating options to easily identify affected processors on end-user systems. In the interim, as a general best practice, Intel recommends that users adhere to Intel default settings on their desktop processors, along with ensuring their BIOS is up to date. Wait a second. Did they ever say they will proactively warn buyers? Seems like they said a lot of words without actually saying, yes, we will do that. Anyway, maybe they'll say more once they have the microcode update available somehow. Anyway, does Intel anticipate the fix that they're waiting on will be effective for chips that have already been in service but are not yet experiencing symptoms, i.e. invisible degradation? Are those CPUs just living on borrowed time? Intel's response is, Intel is confident that the microcode patch will be an effective preventative solution for processors already in service, though validation continues to ensure that scenarios of instability reported to Intel regarding its Core 13th and 14th Gen desktop processors are addressed. Intel is investigating options to easily identify affected or at-risk processors on end-user systems. It is possible the patch will provide some instability improvements to currently impacted processors. However, customers experiencing instability on 13th or 14th generation desktop processor based systems should contact Intel customer support for further assistance. In other words, what they're saying here is that if your CPU already has problems, this isn't going to fix it. This is just going to prevent problems from further developing once this microcode is out, if it hopefully works, which they're apparently still validating. Anyway, what will Intel do for 13th gen buyers after supply of 13th gen parts runs out? So again, assuming you do an RMA to get a replacement, what happens when they run out of replacement parts? Because final shipments were set to end last month. Intel is committed to making sure all customers who have or are currently experiencing instability symptoms on their 13th or 14th gen desktop processors are supported in the exchange process. This includes working with Intel's retail and channel customers to ensure end users are taken care of. Regarding instability symptoms with their 13th core, with their Intel Core 13th and or 14th gen desktop processors. Notice, did they ever actually answer this question, what will they do? Customers will be taken care of. They will be supported in the exchange process. Again, we're not getting a real clear statement of what exactly they're going to do. Anyway, so it does look like that Intel will be applying the microcode to 13th, 14th gen desktop processors that are not yet shipped once the production patch is released. So basically, eventually, once this microcode patch is updated, the new chips being sent out will have it applied automatically, but stuff that's currently being produced right now before that microcode update is shipped and heading out into supply chains and everything, you'll have to update yourself through a BIOS update. Anyway, what, if anything, can customers do to slow or stop degradation ahead of the microcode update? You know, if you have one of these CPUs right now, is there anything you can do to stop from slowly killing it as you're using it right now? Intel recommends that users adhere to Intel default settings on their desktop processors, along with ensuring their BIOS is up to date. Once the microcode patch is released to Intel partners, we advise users to check for relevant BIOS updates. So basically, try to be on one of the latest BIOSes that have the Intel default settings and use that, and that will probably help slow things down until the actual fix, which hopefully works, is sent out later, and you'll need to update your BIOS again. Will Intel share specific manufacturing dates and serial number ranges for the oxidized processors so mission-critical businesses can selectively rip and replace? Basically, Intel's response doesn't confirm that they will do that. Intel will continue working with its customers on via oxidation-related reports and ensure that they are fully supported in the exchange process. Again, via oxidation being a different issue that Intel had a while back. But again, they're not really answering the question on will they share specific manufacturing dates and serial number ranges. Didn't seem to really answer that question. Why does Intel believe the instability issues do not affect mobile chips? And they're saying they're basically continuing to investigate that. So anyway, there's a whole lot of stuff Intel is saying here that just doesn't seem good enough to me. But that's just my take on it. You guys could let me know your take in the comment sections. Oh, and also notice again that they're not really telling you how to tell if your CPU already has issues. One thing they refer to in the Verge article is to go use the, to test if you have problems, use the steps in this, is it Robitech or Robitech? I don't know, but YouTube channel. And as what I can tell in this video, his suggested method is to install NVIDIA graphics drivers a number of times over and see if it triggers issues. He says, like 5 times should be enough. Now, he also stresses to make sure you are on the Intel default profile BIOS before doing this, or else you might just start causing degradation to your chip that you wouldn't want to be doing. So anyway, by the way, oh, and this was Intel's recommended method of testing given in their response to The Verge. But wait, this involves installing NVIDIA drivers. You know, some people don't have an NVIDIA GPU. For example, you might have an Intel graphics card or an AMD one. Anyway, so what do you do then? I don't know. Another interesting take from Intel. So now, how widespread are these issues? We still don't actually know. However, we do know that Intel 13th gen CPUs allegedly have a 4 times higher return rate than the previous 12th gen processors, according to a large retailer. And they also claim that Intel CPU RMAs are higher than AMD. But we don't have, again, specific numbers on how widespread this is. And but the important thing we know now is how good is the Cybertruck PC. It has been tested. It's the fastest Ryzen APU on wheels, so that's good. And you press the hood to start. It looks like the start mechanism is like in the, I think it's in the shocks here or something, where you would like push the hood down and it'll like vroom, start up the engines here. And apparently you can definitely hear the fan noise unless you reduce the power settings. But anyway, that's the important thing today. Another quick note is that NVIDIA's open source Linux drivers have been tested and do have performance parity with the proprietary drivers, which is cool. All right, guys, hopefully you guys found some information here that was useful and or interesting. I'm gonna get back to unpacking some of these boxes behind me. Trust me, there are a lot more where those ones came from. I do have my squat rack set up though, so that took a while, but we got that going. Overall, I'm enjoying my basement setup here, but I think I'm still gonna have to put up some like rugs. You can see the tile floor behind me. I think there's a bit more reverb on the audio here than I liked in my last video, but I don't think it's too bad or anything. Got so much stuff still to do at my old house to get it emptied and ready to sell, and just anyway, so I probably have been a bit slower on producing videos for the channel because I'm in the moving process. That will probably continue to be the case throughout the next week, but we'll see. I'm starting to get a little more settled in. Huge thank you to viewers, subscribers, channel members who click the join button to directly support the channel financially, which helps me do things like, one reason I'm doing this move is to try to run this channel at the same time as I teach full time. One thing about this house, it is like right next to the high school I teach at. I'm gonna be able to like walk out the back door into my classroom pretty much, which is one of the reasons why I'm making this move. To be able to be efficient, right? If I have 0 commute time, that makes it easier for me to run this channel. So anyway, the direct financial support from channel members help make things like that possible to continue doing what I do here. So if you like the testing and news and everything that I'm doing here, and also want me to be able to continue teaching because I do enjoy it and find it very fulfilling, consider giving that support. And in return, you get early access to some videos, member badges in the comments section, things like that, all sorts of cool stuff. And I hope, but I totally understand if you're not in a position to do that, totally okay. And I hope all of you have an excellent day.